Okay, so we're going to continue looking at section 6.3. And today we're going to look at the next two transformations. Okay, these are going to be the stretches or compression. So the first thing we're going to look at is what's called the amplitude. Okay, the amplitude of a sine or a cosine wave basically measures the height of the wave. So if you imagine a line, horizontal line going right through the middle, the distance from that horizontal line to the peak is the amplitude. It should also be the same as the distance from the horizontal line to the minimum. Okay, those should be the same. Now, amplitude is measuring a distance, or it's measuring a height. What kind of number is distance? Anytime you measure a distance, you'll always get a what kind of number? Yep.
Positive.
Positive. So anytime you're asked to identify the amplitude in an equation, the answer is always a positive number. So, how do you identify something as an amplitude change? Okay, first we have to look for two things. Two things I keep telling you to look for. The what and the where. What are you doing? Where are you doing it? With an amplitude change, what are you doing? You're multiplying. This is a stretch. Where are you doing it? You're doing it in front. There's two places you can multiply. You can multiply in front of the function, or you can multiply inside the argument. A vertical stretch, or you can also call it an amplitude change, is multiplication in front. And if I give you an equation and specifically say, what is the amplitude? Like that. If I gave you that problem and said, what is the amplitude? All you have to do is take the absolute value of the number in front. The only time you take the absolute value is if I ask you what's the amplitude. When you're making a sketch, don't take the absolute value, because if there's a negative here, that will do something to your graph. Does anybody remember what having a negative does to the graph? Yeah? It flips it. Flipping it doesn't change the amplitude, but it does change how the graph is going to look. So let's try a couple problems where I just ask you the amplitude of the following. Okay, let me see. If I didn't make up a couple, I'll make some up. Oh, I have some. So we'll do some in a minute. Okay, so amplitude is always positive. So keeping this in mind is going to tell you, if you think about that original table, it's going to tell you what's changing and what's staying the same. Amplitude is going to stretch or compress the graph along the y-axis. So when we do an amplitude change, think about your coordinate. What part of the coordinate is going to change if you stretch or compress vertically? What part of your coordinate would change, your x or your y? Okay. So think about if you had a coordinate at like, let's just make something up, like here. Let's say 2, 1. And you did a vertical stretch on that point. So it's gonna move. It's gonna stretch further away from the x-axis. So if you did a vertical stretch by a factor of 2, it would be up here. So what part of the coordinate just changed? The y. Okay, so the y's are going to change and the x's are going to stay the same. All right, so let's try an example where we find amplitude. Remember, it's just the absolute value of the number in front. And if you're wondering why I'm using C for amplitude, well, you'll see tomorrow when we look at a multi-step problem that this is the third thing you do. But we'll do that tomorrow. Yeah?
Are we not taking a test tomorrow?
No, we're not going to do the test tomorrow in class. I'll talk about that at the end. Okay, 3 cosine x. Okay, what would be the amplitude of that graph? 3 cosine x. Oh, Casey? 3 would be the absolute value of the number in front. So you will have some questions on the test, but that's all you have to do. Identify the amplitude and you just write the number. All right, how about this one? 4/3 sine of x plus pi over 2 plus 6. What would be the amplitude of that one? Yes?
4/3.
Yep, good. It would be 4/3. Okay, what about this one? -2 sine x. What would be the amplitude of that, Jake? 2. That one would be 2. What if I did this? What's the amplitude now, Francesca?
2.
It's still 2. That didn't change it. What if I did this? Yeah? It's still 2. If you shift it up 6 units, it's still 2. Okay? None of the other numbers matter when you're looking for the amplitude. The only thing that matters is the number in front. Negative here, no effect on the amplitude. Effect when you sketch it, yes. It causes a vertical reflection. Okay, and just if you want to hear the what an amplitude change sounds like, well, it's going to stretch or compress the wave. So what do you think the effect would be if you heard a sound like that, and then you heard a sound like that? Yeah.
It's going to change the pitch.
Okay, so it could change the pitch. What else could it change? Yeah.
Would it be like a long, like steady sound?
So the length of the sound is just controlled by when I press the start button and when I press the stop button. So this wouldn't change how long you hear the sound for. But yeah.
Would it be louder?
It would be, okay, it could be louder. So let's try it and see which one it is. And let me play sound. And let's watch what happens as the wave stretches and compresses. So it is volume. Okay, as I stretch and compressed that wave, it did get louder and softer. Okay, so that's what stretching and compressing vertically does. We'll come back to stretching and compressing horizontally, and we'll see what that does next. That's a little more interesting. All right, so let's go back here. So the first thing we have to figure out when we're doing an amplitude change, if we want to sketch it, is what happens to the 5 original points in the table. Well, we just said that the x's stay the same. When you stretch and compress vertically, there's no change to the x values. Okay, so we'll copy those down from the original table. So the x's will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, the y's are going to change. Arithmetic for this is very simple. To find the new y values, take the old y values and multiply by c, where c is the number in front. Don't take the absolute value of the number, just use the number the way it is. Okay, so we'll try a couple examples of sketching a vertical stretch or compression. Now, before I even sketch that, do you think that's going to be a stretch or compression? Which one, Jack?
Stretch.
Yep, that's a stretch. There's no, like, complicated or tricky behavior. If you put a number bigger than 1 when you're doing vertical, it does a stretch. If you put a number between 0 and 1, it does a compression. Like 0.5 would compress it. 1/3 would compress it. If you put a negative with that, well, then it will cause a flip as well. Okay, but there's no negative in this one. Okay, so Abigail, when we do a vertical stretch, what column stays the same? And can you remind me what my original x values are for cosine? Okay, what's the first one?
Oh, 0, right?
Yep,
Pi over 2, pi, 3 pi over 2,
2 pi. And how about, Francesca, what are my original y values for cosine?
1, 0, -1, 0.
Okay, so 1, 0, -1, 0, 1. And Ethan, what am I going to do to all those y values?
Multiply it by 3.
Yep. And let's just go through and write our answers. Chris, can you tell me what I get there?
That would be 3. 0. -3. 0. 3.
Okay, good. On the test, the way it's set up, that is worth 10 points. 1 point for each x and y value you get right. So there'll be a table on Edulastic. You just click in the table, and you just type in whatever you need. If you need to type pi, when you click in the box, there'll be something that pops up, and you can click pi. Questions on the table? Okay, so now my sketch. I'm going to label my x's. Let's go 0, pi over 2, pi, 3 pi over 2, 2 pi. And the problem with a vertical stretch is if you stretch too much, you might need a very big piece of graph paper, unless you change your scale. Don't go by 1s on the y-axis. Let's go by 3s. 0, 3, -3. Because I'm changing the scale, every vertical stretch I do today is going to look the same size. It's the scale that's going to be different. Okay? So, we've got 0, 3. Pi over 2, 0. Pi -3. 3 pi over 2, 0. And 2 pi 3. And draw in your first cycle for the graph. And that's it. So that's a vertical stretch by a factor of 3, which would correspond to a louder sound. Questions on the table or the sketch? Okay, let's try this one. Y equals 1/2 sine x. All right, so the first thing I want you to tell me here is the what are you doing and the where are you doing it. So what operation am I doing here? Yeah? So what, yes, it is going to compress, but what arithmetic operation are we doing that's going to cause that? Jake?
Multiplying by half.
Yep, we're multiplying. Where are we doing it?
In front of the sign.
In front of the sign, not inside by the argument. We're multiplying in front. Multiplying means it will be a stretch. In front means it'll be a vertical stretch. All right, so let's make our table. Tyler, what column here is going to stay the same?
X.
X's. When we're stretching vertically, nothing's happening to the X column, the X's. So Bailey, what are my X's for a sign?
0, 5, 2, 5, 3, 0, 0, 1.
Okay, so we got our X's. And Ashley, what are my original Y values for sign?
0, 1, 0, -1.
Okay, so we got those. And Sarah, what am I going to do to all those Y values?
Multiply them by half.
Yeah, we'll multiply by a half. So Matt, can you tell me what I get when I do all those up?
0, choose a half, 0, -1/2, and 0.
There you go. So there's your tables. There's your table, 1 point, each X and Y value. Okay, now the sketch. Let's label our X-axis. Label your Y-axis, and this time, I mean, you could leave it as ones, and then you could just go in between, or you could label the lines as halves. 0, half, -half. That's how I'm going to do it. So then my coordinates always land right where two grid lines cross. We've got 5 points to sketch. 0, pi over 2 half, 0, -1/2, back to 0. And there's your sketch. All right. Again, it looks the same size as any other function I've drawn, but that's because I changed my scale. Questions on table or sketch here? All right. The last one we're going to look at for this type of transformation technically is not a stretch, but the arithmetic to figure the answer out falls in the same category. What's actually happening in this one? Yeah?
It's getting flipped.
It's getting flipped. So what's my amplitude? Yeah.
1.
It's still 1. Okay, the amplitude is not changing. We're just having a reflection. So x values stay the same. Hopefully if you haven't gotten used to writing these, you will soon. And now let's think about what my old y values are. And Abigail, can you tell me what my new y values are? Yep, so we're going to times them all by -1. And Jack, what do I get if I do that?
0. Wait. Oh, -1, 0, +1, 0, 1. Or is that -1?
And those are my new values. Any question on what the sketch would look like for them? I think the sketch on the test is worth 2 points. I forget exactly. Might be worth 2 points and the table's worth 10, so the table is the most important part. But there's a lot more work to do in the table. A lot more. You have to do 10 different calculations. 5 of them should be pretty automatic because you're just copying them down. But the other 5, they could be as simple as multiplying by -1, or they might be a little more complicated like we did with a phase shift yesterday. You need to find a common denominator.
How are we gonna graph it?
So the graph will be a multiple choice. Yep. Okay, any other questions on this one? All right, so the last transformation that we're going to look at before we do multiple, which will be tomorrow, is a period change. Period change is just another name for a horizontal stretch or compression. Up until now, we have not altered the length of a cycle. Every problem we've done. If you have a graph like this, and you were to measure from here to there, what has that distance been for every problem we've done so far? What's the standard length of a cycle for sine or cosine? Okay?
2 pi.
2 pi. Every problem we've done, you've always had to travel 2 pi units before you get to the next cycle. Well, with a period change, we're changing that. We're changing the period. We can make it longer, or we can make it shorter. Whenever we do a stretch or compression, what arithmetic operation is always involved? Whenever you stretch or compress. Yep,
Multiplication.
always multiplication. Where do you think I'm going to do the multiplication for a horizontal stretch? Yep.
Inside the parentheses?
Inside the parentheses, right next to the x. It's part of the argument. So a period change has the form y equals, could be sine or cosine, a number times x. Again, if you're wondering why I use b, well, that'll be more clear when we do a multi-step transformation tomorrow. This would be the second thing you would look at in a multi-step problem. Now b can technically be anything. It could be a positive, it could be a negative. We're going to focus on examples where it is positive. So since b will never be negative, you're not going to have to worry about a horizontal reflection. That's what a negative b would do. Horizontal reflection. Okay, we could, we're not going to do that. So a period change, it's going to stretch or compress the graph horizontally. Which axis is that? It's going to stretch or compress the graph along the, Tyler?
The x-axis?
The x-axis. Stretch or compress along the x-axis. Now, let me write down 2 things. Y equals sine 4x, y equals sine 1/3 x. One of those is a stretch and one of them is a compression. And remember, this is the horizontal, so the horizontal is always the opposite of what you would think, just like phase shift. Which one of those do you think is a stretch? The sine 4x or the sine 1/3 x? Chris?
The sine 1/3 x.
Yes, the sine 1/3 x is a stretch. Specifically, you could say this is a stretch by a factor of 3. It's going to take the original cycle length and make it 3 times as long. The 4x is a compression. It's a compression by a factor of 4. So it would take the original cycle length and it would make it 1/4 the original size. So in general, you're looking at the b value and you're looking, is it greater than 1 or is it less than 1? But it'll always be greater than 0. If it's greater than 1, that's going to result in a compression. The bigger the number, the more compression you get. If b is less than 1, you're going to get a stretch. The smaller the number, the more stretch you get. 1/10 is going to stretch more than 1/2. 1/10 would make it 10 times as big. 1/2 would make it 2 times as big. Okay. Any question on that? So let's just play an example of a sound. And what do you think is going to be affected when you take a sound wave and compress or stretch it horizontally? How are we going to hear that? Yeah?
When it compresses, the noise is going to get louder, and when or not louder, higher pitch, and when it stretches out, it's going to get a deeper pitch.
Yep, so that's the whole key. When you stretch and compress horizontally, you are changing the pitch. All right, so when we stretch or compress the graph horizontally, we are changing the period. There's a formula that you can use to find the length of the new period. I feel like I've said this before. The formula is 2 pi divided by b. So it's not just b, it's 2 pi over b. And that'll tell you the length of one cycle. Okay. So let's take a look at a couple examples and see if we can find the period. Now, before you even think about finding the period, should this be a stretch or a compression? Yeah.
Compression.
It's a compression. Everything's going to get smaller. It's going to get squished. It's going to get shorter. So the period should compress by a factor of 2. Think about what it was originally. Now it should be half as much. Let's see if that's what happens. What is b in that formula? Yep. 2. So let's fill the b in to the bottom part of the fraction. The top is always 2 pi. So 2 pi divided by 2 gives me pi. And sure enough, that is half as big as the original cycle. Original cycle is 2 pi. That's 1 pi. So it did compress. Let's try this one. What should happen here? A stretch or a compression? Francesca?
A stretch.
A stretch. That's a stretch by a factor of 3. That means whatever the original cycle is, it should now get 3 times as big. Right, let's see. T equals 2 pi divided by, what's my b value? Yep.
1/3.
1/3. And what do you get if you divide 2 pi by 1/3? Yeah.
Wouldn't it be 6 pi?
6 pi, because you're dividing by a fraction, so you'd have to flip it and multiply. So you'd really end up with 2 pi times 3, which is what we said should happen. And the period gets 3 times as big as it was. How about this one. What's my, Ethan, what's my b value here?
Pi.
Pi. And what happens if I take 2 pi and divide by pi?
Pi.
What do I get?
1 pi. Or 2 pi. No. Okay.
No, we don't get 1 pi or 2 pi. It's kind of like if you had 2 times 3 divided by 3. What's 2 times 3?
6.
And what's 6 divided by 3?
1/2. I can't think right now.
What's 6 divided by 3? 2. 2. So 2 times pi divided by pi is 2. So we get a nice cycle, 2. Doesn't have pi in it anymore. That can happen. All right, and the last one, what's going to be the period here? So all kinds of other numbers there, but there's only one you need to focus on. Francesca?
3.
3 is the period. 3 is the B.
Oh.
So 3 is just this.
Oh yeah, that's what I meant. Sorry.
What's the
So
what?
it would be 2 pi over 3.
2 pi over 3. Yep, that's the period. So when we stretch or compress horizontally, what values did we say are changing? The x's. So the y's are staying the same this time. Okay, so now we're thinking about how do we determine the 5 points in the table? How do we determine where they go? Well, the y's stay the same. Unfortunately, the y's are the easy values to work with, but they're staying the same. So we're going to have to work with the x's. The x's are more annoying because you have pi, but we got to work with them. Okay? So y's stay the same. Copy them down from the original table. To get the new x's, take the original x values and divide them by b. Take the original x values and divide them by b. Now, sometimes that can be annoying if b is a fraction. Like, let's say this is one of your original x values, pi over 2. And let's say you were doing a problem where b was a fraction, 1/3. Well, that's a mess. That's what it says to do. Take the original b value and divide, take the original x value and divide by b. But instead of dividing by b, you could also multiply by what? Dividing by b would be the same as multiplying by, okay?
The inverse.
The
Oh,
begins with an R.
reciprocal.
The reciprocal. When I have a fraction, that's how I think of it. Because if you think of dividing by a fraction, the way you would do that anyway is to multiply by the reciprocal. Multiply by what you get when you flip it. Okay, so this is how I think of it some of the time. Depends on the problem. So let's try an example where we make a table. So sine 1/2 x. Okay, what column is going to stay the same because this is a period change? It's multiplication inside. Yep.
Y.
The y's. 0, 1, 0, -1, and 0. Let's put down the original x's. Pi, 3 pi over 2, and 2 pi. What am I supposed to do to all my original x values. Yeah?
Divide by b.
Yep, I'm supposed to divide by b, which means divide by 1/2. I don't want to think of it that way. I could divide by 1/2, or what could I multiply them all by that would be the same? Tyler?
2.
2. Let's just double all of them. And that'll be my answer. 0 times 2 is 0. What's pi over 2 times 2? Yep,
Pi.
pi. Pi times 2. 2 pi. What's 3 pi over 2 times 2?
3 pi.
3 pi. And 2 pi times 2 is 4 pi. Nice pattern. 0, 1 pi, 2 pi, 3 pi, 4 pi. Perfect. And those would be the labels I would use for my x-axis. Put those labels. Let's put 0, 1, -1. And I'll leave the sketch to you. Just plot your points and sketch it. Because I want to do the last question. Let's try this one. This will be the last one. Cosine pi over 3x. Again, it's multiplication inside, so which column stays the same? Yes, Ashley? The y's. 1, 0, -1, 0, 1. Matt, what are my original x's?
0.
Yep.
Pi over 2. Pi. 3 pi over 2. And 2 pi.
2 pi. Let's think of it this way. What can I multiply all of those by? I don't want to think of it as dividing because I have a fraction. Jake?
3 over pi.
Yeah, let's multiply them all by 3 over pi. Okay, what's 0 times 3 over pi? Chris?
0.
0. What's going to cancel when I multiply pi over 2 times 3 over pi?
The pi's.
The pi's. What's 3 divided by 2? Zach? Half of 3. 3 divided by 2.
1.5.
Yeah, 1.5. Here, the pi's cancel. You're left with 3. Here, the pi's cancel. 3 times 3 is 9 divided by 2. What's 9 over 2? Jeff? 4.5. Good. And anyone see the pattern? What's the last one? 0, 1.5, 3, 4.5. Going up by 1.5 each time. Yeah. 6. So that's the first time you've ever had a table without any pi's in the x column. And we can, if we need to do a sketch tomorrow of one of those, we can do a sketch. Okay, but that's the period change. Okay, homework for tonight will be those 8 questions. Okay, I'll put the video online right now. And I think it's already on Schoology. Make sure you show the table. Okay, if you don't show the table, you're going to have to bring that in to show me the next time. The other thing. So the test this week, I think what we'll do for that is that will be a take-home tomorrow from. If anybody has questions or you say, you know what, I can't do it tomorrow because I'm going on vacation, I need to do it some other time, you can talk to me and we'll figure out a different time. But if you are going to be here, the test will be given to you tomorrow and you'll have until probably 10 in the morning on Friday to finish. Because that's when our class is. It's at 10 a.m. And then you might go to the auditorium, I think, for something. Okay, but I'll talk more about that tomorrow, and if the take-home doesn't work for you, then we'll come up with another plan.